Hey everyone, Vessel here again, and I wanted to go over the transforming data worksheet with you and talk about some of the solutions to this set of tasks here. So we're going to jump in and do that. Basically in the front page here is just that summary about what happens when you add, subtract, multiply, or divide an entire distribution by a number or a constant of some sort. We went over this in the intro video, so I'm not going to spend a lot of time on it right now. And then the description formula for a z-score is here as well. So this is one of the probably the most famous way to transform data, is that you can take a list of data points, take away the mean, and divide by the standard deviation, and it creates what's called a z-score. And the purpose of a z-score is to compare data sets that are sometimes uncomparable. It gives us a number of standard deviations above or below the mean. So we're going to look at how that might work in a task here, and then it wraps up with the definition of an outlier, just kind of in a slightly different way than what we've been using. So before, we've been calculating like upper bound or lower bound, and we use two standard deviations to find those cutoffs. Well, that's what a z-score is. It's a number of standard deviations. So another way to find an outlier is just to check and see if the z-score would be above 2 or if it's less than -2, and that's what this says down here. So here was our first task here, and in this one a professional sports team evaluates potential players for a certain position based on two main characteristics: speed and strength. A brief summary of the distribution is in the table below, and it is desirable for a player to run fast, which means lower times, and lift more weight, which is higher pounds. And then the chart here, so we see the mean is given to us, the standard deviation is given to us, even the shape of the distribution is given to us, and sometimes that's information that people gloss over. I think I've got maybe when I see something like this, I get an image in my head of what this histogram might look like. So I want to show you how you might be able to use this to do this question as well. The characteristics of speed and strength are considered to be of equal importance to the team in selecting a player for the position, based on the information about the means and standard deviations of the player and strength data for all players and the measurements listed in the table below for players A and B. So which player should the team select if they can only select one of the two players? And it even says justify your answer using z-scores. So we're going to begin this out by finding the z-score for player A in the time to run. So what you sort of notice is like that 442 is below average, which is a good thing for time. So player A is 4.42 for time. Compared that to player B, 4.47. So A is better here, but the question is like how much better? And similarly, like with the weight, so quick visual, you can see that player B lifts more, but we got to figure out like which one's more impressive. So we only get to pick one of these two players. So let's find the z-score for player A's run. So to do that, it's a really easy calculation actually. We're just going to take our 4.42, subtract away 4.60, and divide that by 0.15. So in this case, -0.18 over 0.15, and that number is -1.2. So the z-score, again, it doesn't have any units because this was in time and this was in time. These were in seconds as well. So the units are non-existent. It's just a number of standard deviations below average. So that's how we interpret this number. Let's get player B's, the z-score player B for the run. And we know this is going to be a little bit worse, but 4.57 minus 4.60 over 0.15. So that number, -0.03. That's just going to be 0.2, 1/5 there. So, sorry, -0.2. So the player A's run is, I'm comparing these two numbers. It's about it is a full deviation better than player B. And you can sort of see, here's another way you can maybe notice that right away. It's a 0.15 second deviation. That's actually the same gap between the two players here. So player A is a full deviation better than player B in the run. When you switch that over to the lift, the z-score for player A on the lift is 370 minus 310 over 25. And this number, what do we get? 60 over 25, 2.2, I believe. Let me just double check that. 60 over 25, 2.4, 2.4. And we're going to double check that with player B. 375, so this is a little bit better. Whoops, minus 310 over 25. So that's 65 over 25. That's going to be 2.6, I think. Yep, 2.6. So, in general, both of these players are way better than their peers at lifting weights than they are at running. These guys are both over, they're outliers actually in both cases. 2.6 and 2.4 are both outliers, way above average essentially is what this means. Whereas the run, they're not quite as impressive as the group, but player A is quite a bit better than player B in this case. So this will lead us to conclude that we should be choosing player A here. So since player A is a full deviation better in the run than player B, but only 0.2 deviations worse in the lift, player A is the correct choice. Sometimes people think there's not a right or wrong answer if you just have an opinion on this, and that's not the case. You actually can only choose player A in this case because of the fact that player A is a lot better in the run than player B is, and they're pretty close together in the lift. And I actually wanted to add on to that too, just for a second here. So remember earlier on I mentioned the shape of the distribution. So one of the things I went and did is I just I get an image in my head. So I made this display. So here we go, that'll work. So this is the time display, and again, it's just a rough sketch. I don't know exactly what the distribution looks like, but I do know that the mean was 4.6, the spread was 0.15, and it's a skewed right distribution. So I tried to just illustrate what a skewed right distribution might look like, and I put some numbers on here, and the mean is going to be a little bit to the right of the peak because that's the shape. If the shape's skewed right, then the mean's going to be a little bit to the right. So it's a rough sketch. It's not perfect by any means, but it gives me enough to go off of here, and I think it's a nice illustration too. So we knew that player A ran 4.42, so that's about here. So you can sort of see there's very few people that are faster than player A here, and if I use player B's time, I should maybe write it down. Player A was 4.42. Player B was 4.57. Again, a little bit above average, but pretty close to average. So this is how many players beat player B percentage-wise, just sort of shading it. Just give me an estimate for what's the shaded region over there. And so you can see player A's better. And I'm going to switch it down here with the weight in pounds. So we had player A, I'll use purple again. Player A lifted 370. Again, rough sketch, about here. Player B lifted 375. And you can sort of see right on the scale just how much more similar these two numbers are than these two. So you could even shade. This is how many people beat player A. So it's not too many. Same with player B. Again, they were outliers. And the other clue, I didn't mention this, the other clue I had to draw it said it was symmetric. So just kind of made a fairly equal sized hill. And what I'm doing here is just taking a general histogram, which I don't really have. And I'm just sort of imagining what a smooth curve over that would look like. So it's just an image that helps me sort of confirm what we did here. And again, I'm sure most students didn't make these displays or even thought about them, but one of the things that I start to think about when I see information about shape is I try to think about like, well, what would that look like and how might that impact what we do. So that part just kind of helps me sort of think about like where these numbers fall, the shape of the distribution. So hopefully that helps, makes a little more sense out of this situation here. But essentially what these z-scores tell us are how well a number is above or below average. So that's what you can use to compare here, and in this case player A has to be the correct choice. On number 2, here we go. It's about this gas tax problem here, where we have gasoline prices have increased in recent years. Many drivers have expressed concern about the taxes they pay on gas. So in the U.S., gas taxes are imposed by both the federal and the state. So this box below is just the state gasoline tax in cents per gallon for all 50 states. So we get, and a little outdated now, but we have all 50 states worth of data here. We just get the box plot of that information. And then again, it's in cents per gallon state. So always pay attention to units, and we'll see what we're going to do with this actual box plot here. What are the approximate values of the median and the IQR for the state gasoline taxes in cents per gallon? That seems simple enough. Median and IQR. Mark and label the box plot. Okay, that's pretty straightforward, I think. We're just gonna estimate that. That's 20. That's 22.5. Let's call this about 21 cents. So let's say the median is about 21 cents. And then the IQR, let's see, Q3 looks like 25 to me. And then Q1, let's say Q3 is 25, Q1 is 18. If you have a slightly different number, that'll be okay. We're sort of estimating it using our eyes here. So the IQR in this case is 7 cents per gallon. We've got to subtract those two. So here are our two statistics, and we've got them sort of labeled here. Here's our IQR, and in the center here we got the median right there. So not too much to do, just be able to read a box plot. Part B, it says the federal tax imposed on the gasoline was 18.4 cents per gallon at the time the state tax were in effect. So the federal gasoline tax was added to the state to ensure, for each state to create a new distribution. What are the approximate values in cents per gallon of the median and IQR of the new distribution? So this is getting at that idea of what happens when you add a constant, in this case 18.4, to every data point. So sort of a visual here. If we kind of estimate that number there, it doesn't even matter what I think it is. Maybe it's 7.5, 8, somewhere around there for the state. If I'm going to add on my federal tax of 18.4, I can just move 18.4 over, and the minimum is going to go from 6. Just move it over to about 18 spots here. Maybe it's about here where the minimum might be. It's adding on 18.4. But what's going to happen to every single state is this entire box plot's just going to shift 18.4 spots, basically. So I'm going to have this exact same image, except it's just going to be moved 18.4 units. So if this was at, we called that 18, if I add it on, now it's going to be right here around 36 cents. Again, just kind of an estimate. 18 plus 18.4. If the median was 21, if I add on 18 to that, it's going to be about 39. Roughly here. It's hard to do without the scale there anymore, so it looks something like this. This one gets added on a little bit more, and then this one, it's going to have the exact same length. Everything's going to be the same except it's been shifted over. So how does that compare for our new median? The median for federal plus state is just 21 plus 18.4. Oh, sorry. The median of the federal plus the state is 21 plus 18.4, or 39.4 cents per gallon. And the IQR, what's that going to do? Well, if I have this number goes up 18.4, Q3, and if Q1 goes up 18.4, and I subtract those two numbers like I did before, my IQR is still 7 cents per gallon. And I could sort of show it this way, I guess. Q3 and Q1 both increase by 18.4, so the IQR remains constant. And again, in general, that was what's in the box on the front page. If we add or even subtract a number to a distribution, stuff like median, mean, the individual statistics, IQR, or, Q1, Q3, max, min, those all change by that same constant, where measures of spread don't. You know, the spread's going to all stay the same because we're just shifting everything. So next, on the last part, it's, again, one of the themes of this one. It's got a lot of different text in it. So this one's about cereal boxes. It's kind of interesting that you know, the amount of sugar in a serving of breakfast cereal. A student randomly selects 60 boxes of different types of cereal from the shelves of a large grocery store. The student noticed that the side panels of some of the cereal boxes showed sugar content based on 1 cup servings, while others showed content based on 3/4 cup servings. Many of the cereal boxes with side panels that showed 3-cup quarter servings were ones that appealed to young kids, and student wondered whether there might be some difference in the sugar content of the cereals that showed different size servings on their side panels. To investigate the question, the data were separated into 2 groups. One group consisted of 29 cereals that showed 1-cup serving sizes. The other group consisted of 31 cereals that showed 3/4 cup serving sizes. So we've got the 29 and 31 in the 2 box plots down here, and then we get the box plots again and their sugar content in grams per serving. So you can kind of summarize, you know, if you check your cereal boxes at home, some of them are going to be 1-cup servings, some of them are going to be 3/4 cup, and these ones tend to be the ones for the more appealing to kids, like your sugary kind of cereals. So just looking at the sugar contents on these 2 different distributions, write a few sentences to compare. So we're going to do the big 4, shape. In this case, I think it's pretty likely that the 1 cup is skewed to the left. You got this longer line here, longer on both sides here, measuring the median to the Q1, compare that to median to Q3, and then median to min, median to max. So those are quick visuals you can do. So we likely say this is skewed left. Where this one's pretty symmetric, you know, this does have a longer line here. I could see a student saying that this one might be slightly skewed left as well. I'm going to lean towards symmetric based on the fact that the middle of the box is where the median lies. So I'm going to go with fairly symmetric in this case. Again, box plots can be tricky for shape, a lot harder than doing a histogram, but it's okay to use softer language on those. So the 1 cup serving size, sugar content distribution, got to get it in context, is likely skewed right. Whereas the 3/4 cup looks fairly symmetric. All right. Next one's probably the easy one, outliers. It doesn't say, we don't have to calculate outliers. We can tell there aren't any. If there were outliers, they would mark them with a box plot. And the other way you can tell is the width of the box is extremely large relative to how long the line is. So there's no outliers in either of these. Neither distribution has outliers. Center, I'm going to go with median here since it's really the only one I've got to quickly compare. So I'm going to give, the numbers are pretty easy in a box plot to estimate it. So it looks like I got about 10 here and a little bigger than 12. I don't want to go as bold to say it's 13 either, but the median for 3/4 cup, I'm just use the word approximately 10 grams of sugar, whereas the 1 cup, I'm going to say it's about 12.5 grams of sugar. Seems like it's kind of between the 12 and the 13 to me, so about 12.5. So yeah, I can just give a real quick comparison with the 2 values, and you don't have to say it's higher or lower in the case. It's clear you've listed the value. So sugar content for the median is a little bit lower for the 3/4 cup. And then spread, I'm going to use both again with the box plot. IQR is really quick to compare, and so is range. So both of those. So I'm not going to give the specific statistics in this case just because we don't have to. The range and IQR for the 1 cup servings is greater than the 3/4 cup. You got to make sure it's in context at some point. So using the fact that it's about sugar, make sure that if you, and this is a choice on your part, but pick at least one measure of center, at least one measure of spread. If it's easy to get 2 of them, go ahead and do 2 of them. And it's important if these are different, for sure. Like if the range was bigger for one and the IQR is bigger for the other, you want to write about that sort of thing. But basically, what you want to do is, if a person were to read these 4 things, they'd be able to recreate this display, with an image in their head, just based off of the phrasing that you used. So in this particular case, all the criteria I met, we've done the big 4, and that's what we do to compare. So how does this change here? So with this next section, what happens is that it seems kind of weird to compare the 2 different sizes of cereal. So like one, a cup versus 3/4, it's different. So what would it look like if they actually said the same amount of cereal? How would that change this display? So after analyzing the box plots on the preceding page, the student decided that instead of a comparison of sugar based on serving, it might be more appropriate to compare sugar content for equal size servings. So to compare the amount of sugar in serving sizes of 1 cup each, the amount of sugar in each of the cereals serving 3/4 cups was multiplied by 4/3. So if you have a 1 cup serving size and you just put a cup of cereal in a bowl, that's all good. You're just going to leave that there. The sugary cereals, basically, the 3/4 cup size, if I put the same amount of cereal in it, now we're comparing those. This is the sugar content now that if I have the same amount of cereal. So it's basically just took that previous page, or that previous box plot, and multiplied all those numbers by 4/3. So you could multiply the minimum by 4/3, this one. There were 31 boxes in total. All of them get multiplied by 4/3. This is that box plot. So it's going to create a little bit larger spread, and it's also going to change your median and your mean and all those values by a factor of 4/3. So what new information could be provided? I think there's 2 that stand out a lot to me. The medians, are now, actually this one passed it. So the median for the 3/4 cup passed the 1 cup. Before it was around 10. Now it's up, 4/3 times 10. So it's a little bit bigger than 13. And now the maximum is even greater than the 1 cup, where before the maximum for the 1 cup was quite a bit more than the maximum for the 3/4 cup. So those are the 2 that stand out, and I think either one of those would be appropriate for this response here. So the median and maximum for the 3/4 cup serving sizes are now greater than the 1 cup. So just that multiplication factor, it makes the spread a little bigger, but the IQR is still bigger for the 1 cup, and so is the range. The range is still bigger for the 1 cup, but those big differences was definitely the median, and now the maximum is greater in this case. So in this case, like based on the box plots, how would you expect? This is a cool question. The mean amounts of sugar to compare for these 2 cereals. So this is kind of can be a difficult question. What it relates to is the shape, actually. So we know where the medians fall, and one thing that happens, like we mentioned before, if this is likely skewed left, and this one's likely symmetric, what that tells us is that when a distribution is skewed, the mean will pull toward the skew. So the mean is going to be this way of the median. It's going to be a little bit lower than the median. And in a symmetric distribution, the mean is pretty close to the median. So in this particular box plot, it's pretty safe to say the mean adjusted sugar content will be lower for the 1 cup serving size because the distribution is skewed left. Causing the mean to be lower than 13 grams. Now, and again, I can't really get an exact number by any means in this display. Like this was, we said it was about 12 and a half before, so it's going to be lower than that. Where this one's going to be pretty close to 13. So this one is how we attack this question. So again, it has to do with how skew can pull the mean. And that wraps up this video. So thanks for checking this out, and I hope you enjoyed it and got some information from it. And there'll be more to come. So have a good one, and I'll talk to you soon.